Hey everyone, this is Carl, and I'm just going to go over just kind of simple trending with respect to kind of the average annual growth rate. In terms of this discussion, it's really what we're really getting at, and the genesis of it is kind of the percent change between and across these years. I know there's average annual growth rate calculations with only exponents, but particularly just for this, it's more of a simplistic version of trending. We're not going to get any exponents in this in terms of getting more accurate or as accurate as we can be with respect to these future years, but rather it's more getting an idea of how the percent change between years and how that works and what that looks like if you, in a very rough estimate, take it forward. So this is just kind of the genesis of the question in your homework and just kind of an example of how it's processed and calculated. So just looking at this, it's very similar. We have 500,000 in sales in 1999. By 2015, we have about 6 million. And so what we want to do is just very rough the percentage change with respect to this in 2016 and 2017. What would it look like if we just look at it more as a linear graph? And so the key point in that is first identifying the first and last years and identifying the number of years. And you can see right now we have 17 years. Just simple kind of calculation here, but you can also do it by hand. This is a 17-year span. And what we want to do first to calculate the difference is we're taking our new value. So in our Excel, we're going to take our new value of 6 million, which represents 2015, minus 99, our very first year of sales. And then we're also going to divide by this first year of sales right here. And this will give us this value. Now, I already formatted it as a percent, but just so you know, when you do this formula, the number as a number, it means 11. So when you're doing this in the numeric, remember that in terms of this, the whole number represents a percent. So if it's 1, that represents 100%. If it's 2, that represents 200%. And if it's 11, it represents 1100%. Now what does that mean? And so in our case, this means that between 1999 and 2015, there was an 1100% change, and in terms of what we're talking about, the growth of it. So it grew by that much over the course of this. And what we want to know is just what was the average percentage growth per year, and what would that help us with is just applying that to these future years, just a very rough estimate, just to understand just percentages and trends and the like, just not getting too granular or kind of the complexities of it all. And so simply to do that, it's just this divided by, now remember, we started out at that. So it is 16 because the percentage changed. Like there wasn't any percent change leading into it. So 0.68%, 0.68. So now what we have here is that means that by each year there's about a 68%, 69% change between kind of going across. So, and remember just to check that out, you're getting at the percentage again, just for understanding the concept of it. So 68.8% per year. So here to here, 68%, here to here. And if you really want to know just kind of why that's the case, just think of it, just looking at it even manual. So it means from here to here is 68%. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So there's 16 changes in the dollars, which means that we're 16 points of increases. So that's why you divide by 16 and not 17. Nothing happens leading up to this. So that's why we get this value right here. Just an important fact to keep in mind, and that we've adjusted in the homework. So in plotting that forward, we want to just ballpark, remember, ballpark estimate. So the 6 million, we want to multiply it by 1 plus this value. Now why is that? So it's 0.68, just ballpark. And what does this mean? Why are we multiplying it by 1 plus this? Well, the key in this is the fact that we don't want to subtract. We don't want to take 68% of 6 million and then call that the 2016 estimation. Rather, we want to multiply it so we keep the 6 million, but we add 68% of that 6 million to it. And to do that is multiplying by 1 plus the 68%. This will give us the 6 million plus the 68% of 6 million will give you this trend. And so by doing that, you can see it increases by this much. And in the same vein, you could do it again, just to get you here, so by 10 million, just to check it out, plus 0.68, just ballpark estimate. It gives you, we can format it, just to make sure, just to give us our sense of dollars, so we can kind of see holistically what we're looking at. You can see the trends right here. Now, in terms of financially speaking, this might be a cruder way to kind of estimate 2 years in advance of this, but it also kind of gives you a sense of just if you look at this as a linear relationship, just what it would look like. So this is kind of what we're looking at, just a ballpark estimation using 2016-2017 based on the percentage change, plus on the average growth per year. In our sense, the average percentage growth per year. So we just let us know if you have any questions. We've just posted the tutoring schedule, so just looking forward to assisting you this semester. Thanks so much. Bye.